Hello? Test 1, 2, 3, 1, 2, 3. Orange juice. Oh, we're live. Good. Sorry?
You are asking to do something for us. Do you have any questions for us?
No. Well, maybe one. I can't get the clicker to work. It acts as a... I don't know. Well, I'll use the keyboard instead. As soon as I can start, let me know. Because I got 121 slides and 25 minutes. Am I good? Really? Oh, cool. I get 2 additional minutes, so that's good. Welcome to Designing and Building Cost-Effective Home Labs for AI Workloads. This is going to be awesome, I promise you. Tony is waving. Yeah, good? Okay, good. So my name is Johan van Amersfoort. I'm a chief evangelist at ITQ. I work in the CTO office, and I'm responsible for running some R&D projects, of which a private AI solution is part of one of those projects. And I won't cover that project in detail, but I'll share something about it in a bit. So building a cost-effective home lab could be interesting. So who's already doing something with AI? Cool, couple of hands. Are you running that in a home lab? Yeah? Yeah, well, yours doesn't count. And I'll cover that in a bit as well. So this guy, Jensen, CEO of NVIDIA, he announced some really cool stuff at GTC earlier this year. The Blackwell architecture, really cool, like GPUs with, I don't know, 128 gigs of frame buffer and like 20 petaflops of performance, and really, really awesome. And the DGX SuperPod, that's really cool. No one has it. Hardly can imagine that anyone can afford it. And this certainly doesn't fit in a home lab. NeMo Inference Services, NIMS. Anyone played around with it yet? Yeah, Tony, okay. Cool, well, I'll go into detail on what a NIM is tomorrow, and I'll share a bit about it just later. But the question is, will all of this, what I just showed, run in a home lab? And, well, the question is not, will it run in a home lab, but how will it run in a home lab? Because, spoiler alert, this can run in a home lab. And another spoiler, you don't need GPUs to do so. So that's one of the biggest misconceptions. You need a GPU to run an AI workload in your home lab. I'm going to show you that that's not the case. It will help, but it's not mandatory. So it depends. Who knows this guy? One hand, Mark Hubbard. Okay, so this is, he calls himself the home lab king. And Mark Hubbard has a bigger infrastructure in his home lab than the average customer I work with. So I don't know if you can call it a home lab, to be fairly honest. But we're going to do some myth busting. And AI, when we talk about AI nowadays, we mostly talk about conversational AI. But there's much more types of AI that you could run in an infrastructure. And I'm going to focus on 2 types of AI today, which is conversational AI, and the other one is computer vision. So let's dive into conversational AI first. And I decided, so I have ran in my home lab, I would say roughly between 8 and 10 different AI-related solutions and projects, and build them myself. So I had to choose a couple of them, and I chose 2. One, which I call Project Kobe, which is a communications operations bot for information exchange. That was just a project name. But I wanted to figure out if I could build a chatbot based on my own books and just ask questions about my own books. And the second one is my latest project, and I'll share that in a bit. And that's based on computer vision. Now, Kobe uses a GPT-3 model. It's LangChain based. LangChain is a framework to build chatbot-based applications. I trained it with VMware Online documentation. So I basically pulled every single PDF I can find on Horizon and Workspace ONE, and my own 2 books, VDI Design Guide Part 1 and 2. And it runs in my lab without the GPU. So that's pretty cool. So I'm going to show a first demo. This is the actual application. It is fairly simple. The only thing you need is an OpenAI API key, some PDFs, and what you do is basically, and it's quite hard to see, but you upload some documentation. It basically asks questions. In this case, who is Johan van Amersfoort? He's the author of books, blah, 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 blah. And it takes that information out what we call a vector database. A vector database sits next to a model, and the vector database is used to store the information in. Is it the year of VDI? Well, apparently I think it's not the year of VDI. But you get the idea. The question is why isn't the GPU required to run such a workload? And I'll quickly go through this. What I did is I built an application which is hosted on Hugging Face, and I'll share a QR code in a bit, in which you can pull the application yourself and run it on basically any infrastructure that runs Docker. In my case, I'm running it on a Synology NAS, which supports Docker, which has a couple of CPUs in it, and it's a couple of cores. And it's fairly simple. Just pull the container, run it as a web service, and you have the application running. So, who has played around with Hugging Face so far? Okay, a couple hands. Let's show a demo of Hugging Face, and in this case, the Kobe application. So what you see here is what you call a space. It is an application. And what's really cool about Hugging Face, and you can see it's a bit alike or comparable to GitHub, but in this case for data science applications, you can copy the Docker run command here. So if you have an endpoint that runs Docker, you can just simply paste the command and it runs. But you can also host it and run it online on Hugging Face. And in this case, it runs on a free instance with 2 virtual CPUs and 16 gigs of RAM. But running it on a full T4 with 16 gigs of frame buffer only costs 60 cents an hour. So if you want to try something with a GPU, it's fairly simple to do so, and you don't need an infrastructure. And in this case, you see the same application, but in this case, hosted at Hugging Face. And again, I don't need an infrastructure to run it. Completely free, based on modern frameworks. And if I change something in this application online, like a piece of code, or I replace one of the logos or whatsoever, it automatically rebuilds and just pushes the application online again. And if you then want to run it in your home lab, the only thing you have to do is copy the Docker command and pull it in your own environment. If you want to play around with this, that's the one you want to take a picture of. The reason why I started this project is because I wanted to learn about a RAG. An application you use to augment basically the information you have yourself on top of a model and make a chatbot available to ask questions about your own documentation. And in our case, and I'm going to cover that tomorrow in another session, we wanted to do that based on the Private AI Foundation platform. So tomorrow I'm going to talk with Frank Denneman about Project Einstein, an internal R&D project that we run at ITQ, where we actually do this based on the Private AI Foundation architecture. And there's a really awesome demo that we're going to show tomorrow on how we integrated Microsoft Teams into this environment. So it's fairly simple for an end user to consume an AI application without having to run like a separate web service or whatsoever. So it's really simple, and it's from an end user perspective has a really great UX. So that's tomorrow at 2:15. So now I'm going to talk about computer vision. So this is a project I'm particularly proud of, and I'm going to show some more details on how I built this. So the project is called Project Lola, and Lola is the neighbor's cat. And Lola is a Maine Coon cat, which is extremely big. Anyone knows what a Maine Coon is? Okay, a couple of hands. It's the biggest domestic house cat you can basically buy. The turds are bigger than mine, and it shits in my garden. Small disclaimer, project isn't finished, but I'm going to show the process so far, the progress so far, and the results so far. So the objective is avoid turds in my garden, use AI to detect Lola. I presented this as a Kubernetes meetup, and at the end of the session, I basically asked questions to the audience, like, what do you want to know? And one of the guys in the audience asked me, like, why didn't you buy a dog? Yeah, I could have bought a dog. That would be far simpler, but I'm a nerd, so I like to nerd out. I wanted to, as part of the project, master the art of Kubernetes. That failed miserably. I can barely spell Kubernetes. I wanted to learn about platform engineering, which is really cool. And I wanted to avoid a war with the neighbors. And I always use this meme when I talk about AI. And I wanted to debunk the meme as well. So I had a couple of requirements. Obviously, no new infrastructure from NVIDIA. So it needed to be low-cost infrastructure, low power consumption, resilient, fully automated, kid-proof. I have two small children, one of two, a boy of 2 and a girl of 5. And I had a game plan. So Lola, I bought a shit ton of Ubiquiti security cameras secondhand on eBay. And I used NVIDIA DeepStream, which is a free SDK that everyone could just download, install, and use. Fairly simple to consume as well and integrate in your own environment. And it has an internal pipeline of different steps that you can use, but also use the step to trigger some things. So in my case, I'm using Scripted. Anyone familiar with Scripted? Free tool, lets you manipulate every single video stream there is and send the stream to home automation devices, like a Google display or an Alexa display or like something else. So you take any video stream, import it, and it sends it to modern devices that cannot directly talk to an RTSP stream. So I got Homey. Anyone familiar with Homey? Okay, it's a Kickstarter solution of project originated, I think, roughly 10 years ago. And it is kind of Home Assistant, but with its own device and all types of receivers internally in the device. It's really cool. So what I do is basically, as soon as the inference engine of DeepStream detects that Lola is in the garden, I want to first trigger Scripted to send out the video stream to my Google displays. And I want Homey to send a push notification as well that Lola has been detected in the garden. Then I want to trigger the watering system and shower the cat. That's the whole idea. Well, that failed. So step 1 is to build the application. And DeepStream is really cool. It's a free SDK, but it's used by multiple large governmental organizations, like the defense organizations. Some police organizations are using it, for instance, for to detect license plates, stuff like that. So it's a real enterprise-grade solution, and you can just freely download it. So that's pretty cool. It has multiple different steps in the pipeline, different features that you could use. And what's really cool is that you can both use it on GPU as well as CPUs, but it supports all sorts of accelerators. And you can download it for free using the NGC platform. So NVIDIA has a platform, a repository of applications, SDKs, models, NIM. What I talked about briefly is also available on NGC. And you can download everything just as a Docker instance, a Docker container. So ngc.nvidia.com, the only thing you need to do is create a developer account, and then you have access to everything. So Deepstream is available on there for different types of platforms. You can run it on a DGX platform. You can run it on infrastructure with L40 devices or other types of GPUs, but also for the Jetson platform. And that's really awesome. Who knows what a Jetson Nano is? Who does not know what a Jetson Nano is? Ooh, that's going to be good. Who's played around with Jupyter Notebook? Okay. First demo of Project Lola. What you see here is kind of an online IDE based on a web interface. This is based on Jupyter Notebook, and what you basically do here is you have interactive access to both a console as well as code output, and you can basically manipulate the code on the fly, and data scientists use this to directly see what the impact of their code is to data. And in this case, I created an application. I customized a couple of the inputs, and you can see here there's a ton of labels, and a label basically is something that it should be able to detect in the video stream. So I started the application, and like I mentioned, it has, I didn't mention that, but it also has console access. So you can see the output of what you're doing in the console of a container. And that's one of the things that a data scientist on average uses as well. They want to have access to a console. But if you provide them with a Docker container, honestly, you don't want to give them SSH access to the container. And you can all secure that using the Jupyter Notebook. So it's a really powerful solution. And it comes with every single NGC container you download. It's just part of the container. So the only thing you have to do is expose the Jupyter Notebook to the outside port and configure a username and a password, and you're done. So application build. Step 2 is to build the infrastructure. Like I mentioned, Deepstream is available for different types of GPUs. I have such a GPU in my home lab, but that's not what I wanted to test. That's not what I wanted to build, and this is also not cost effective. This is going to be a little bit more cost effective. So this is an RTX 6000, which you can pick up on eBay for roughly 900 euros. So that's around, I don't know, $1,000. If you want to make it more cost effective, you can run this on a GeForce GT series for $60 on eBay. The thing that it needs to support is a minimum CUDA version 10.2 by heart. And this card supports that. But what I wanted to do is nerd out on Jetson Nanos. So a Jetson Nano basically is a Raspberry Pi on steroids. It has similar ARM architecture. It has just as much as 4 gigs of RAM. But what it also has is 128 CUDA cores. So it has a Maxwell GPU. Similar architecture as the M60 or the M10 that people that work with VDI probably also know. And it costs roughly between 100 and 150 euros. So what I did, because resiliency was one of the things I wanted to achieve as well, is I took my 35-year-old Legos. I bought 2 second-hand Jetson Nanos. I used the VExpert NUC. Who has the VExpert NUC of a couple of years ago? Really cool device. So I used the VExpert NUC as well. And I bought a 35 euro Ubiquiti switch. Installed Ubuntu 2004, K3S, which is a lightweighted version of Kubernetes, and Jetpack, which consists all of the things that you need from an NVIDIA perspective and Docker. So cost, 2 Jetsons, a switch, and some SSDs. So extreme good value for the power that you get out of such a platform. And it uses 30 watt on full performance in total. So the spouse acceptance factor was definitely met. Some specs, like I mentioned, I think the most important one is the Maxwell cores. And it runs Jetpack. So again, Jetpack is basically an entire set of solutions that you can just image on an SD card, run it on the Jetson, and you're done. And I needed to do a couple of things in order to make Kubernetes work with the NVIDIA devices. So first of all, you need to install the container runtime. And you need to test the GPU support running with that container runtime. And I'll make sure to share the slides afterwards so you don't have to take pictures. So at the end of the adjustment and the testing of the container runtime, we got a pass from testing that. Then I could install K3s as a lightweight Kubernetes platform. Then we had to use run device query on the pod to test if Kubernetes was capable of retrieving the GPU information as well. So both nodes worked out well, so that was good. Then I created a pod, so an application running device query. Same thing. So next thing was to test an application. In this case, TensorFlow, a simple call to TensorFlow to see if it works as well. Same thing, result passed. By the way, the last 10 slides took me roughly 2 months to figure out. So it's not that it was just done overnight. And I'll share a link that will help you to build it yourself. Next step was to run the application on K3s. So I created the YAML and a small disclaimer. I know that I shouldn't be exposing the host network to an application. That's not the way to do it. And also, I shouldn't be allowing host access or root access to the application. But just for the sake of this demo and the fact that I want to get rid of the cat of the neighbors, we need to pull that off. Next demo. So this is the actual demo of the application. I'm going to show the raw RTSP stream coming from the Ubiquiti camera. I'm going to start the deep stream pipeline with a ResNet model and show the utilization of the Jetson node. And show some results in VLC. So VLC is the easiest way to import an RTSP stream. So you saw the raw video stream. I'm going to start the pipeline from the Jupyter Notebook just by executing the last cell. And what it now does is start the application. And what's really cool, and you'll see that in a bit, is that it'll accelerate. It uses the GPU on the Jetson device for multiple reasons. Not just for computational reasons, but also it has encoders and decoders. So you're going to see here the hardware engines. These are the encoders and the decoders. But you can also see that the GPU will, in a bit, will be utilized. And it's accelerating a Python command. So that's the actual application that we're running. So you see that the encoder is doing its thing. And now we can open up the video stream that's being the video output from the Jetson. That's what you see here. So you see the video stream. You see me there. It's a bit laggy. And I'll explain in a couple of minutes why that is. But it works, right? So it does detect something. It uses deep stream, detects something in the video stream. So next demo is to test the application with my cat. So that's not Lola, that's my cat. So that didn't work. Then I needed to teach a model what a cat is. So ResNet is a fairly older model. I didn't want to build or adjust a fairly old model, so I used a framework called YOLO, not #YOLO, but you only look once. And it's much faster than ResNet. ResNet is an RCNN, and YOLO is much faster. And you'll see that in the next demo. So you can already see that the frame rate is a lot better. So what I'm going to do now, because my cat just ran away, is I'll pick up the cat, and come back. And with the trained model, with cat information in it, I'll show it in front of the camera, and it does nothing. So the objective was Lola, not my cat, but Lola. So what I did next is like, if a cat doesn't, collaborate, I'll do it differently. So I took my iPad, took a picture of Lola. It recognized the chair. I thought, well, there's background in it. It's not trained well. Let's take away the background. Still nothing. Then I took just a random picture of a cat. And there you have it. It recognizes a cat. Not my cat, not the cat of the neighbors, but it does recognize a cat. Jet-lagged. Preliminary conclusion, failed for now. I have some next steps. I'm going to train a custom model on different cats. I'm going to implement networking and load balancing like it should. I'm going to share everything on GitHub. So if you want to play around with it yourself, I'll share the link there. Just keep track of my social channels and my blog. And I got some valuable resources to share. So who's played around with Launchpad? Okay, one hand. You earn a token. Really cool. It's basically hands-on labs for NVIDIA-related workloads. Who has done a course on the DLI, Deep Learning Institute? No one? Completely free courses, full day, in which you actually build applications. They're the best. A lot of companies should follow that example. It's really good. And finally, I use this article to build the environment on the Jetsons, to build the cluster, to test out the cluster. This is real. If you want to build it yourself, this is definitely a helpful resource. So to conclude, a couple of key takeaways. Not every AI workload requires a GPU. Playing around doesn't require a home lab, but it can help. And if you want to accelerate, there are definitely cheap options. A GeForce is maybe your way. 5 minutes? Oh, really? I thought I just 20 seconds left. There's a ton of useful resources to start. I would definitely look at the two previous NVIDIA platforms, so Launchpad and the DLI. And some considerations when it comes to home labs. So if you want to run and accelerate like a conversational AI application, frame buffer is key. So there are different types of Llama models. There's Llama 3 8B, there's Llama 3 30B, 13B, and the number of parameters will impact the frame buffer, so the video memory you need to run such a model without anything next to it. So just serving the model through an inference server requires frame buffer, and the more parameters you feed into the model, the bigger frame buffer needs to be. So in the demo we're going to show tomorrow, we're running a RTX 6000 Ada with 48 gigs of RAM, which can support the Llama 3 30B model. And it runs relatively smooth. But if you want to run bigger models, much more models, then you definitely need an infrastructure like I showed at the beginning of the deck. So any GPU that supports CUDA starting from 10x will definitely run DeepStream. So if you want to play around with DeepStream, that's what you need. And what's really cool is that also Intel and Google have accelerators. Intel released a generation of CPUs last year, which have an AMX part to the CPU, which means that they can run matrix computations inside the CPU. You don't need an accelerator to do so. So running an inferencing application, like maybe part of the DeepStream framework, can work on a CPU. It just needs to support those calls, those API calls. And looking at what Google is doing with their Coral accelerator, basically based on a flash drive, you just insert it and it has tensor cores running inside the device. It's also a cheap option to play around with an accelerator. So yeah, definitely something to check out. Are there any questions? Do we have a mic or? Yeah, we have a mic.
Why did you use NVIDIA chat with RTX instead of Project Hope?
Yeah, so why didn't I use the RTX chat application from NVIDIA? Well, that would be, honestly, that would be too simple because you can just download the executable, run it, it detects that you have an RTX board, and that's it. I wanted to see what is necessary to run a RAG application locally. And to be fairly honest, the footprint of the RTX chat app is fairly big. You need, I think, at least 24 gigs of frame buffer in order to run it. Whereas I wanted to first check out if it's necessary to run or to have a GPU or some kind of accelerator to run such an application. And I just showed you don't. But it is, by the way, it's a really good choice. It's fairly simple to deploy, and if you have a gaming board with RTX capabilities on it, it's definitely something to check out. At the Spring booth or the Spring Theater, Deshaun Carter is also walking around, and he runs models and RAG-based applications on a Raspberry Pi cluster. So that doesn't even contain any GPU, and he runs vector databases on it as well. So if you want to know more about that, I would definitely check out Deshaun at the Spring booth. Any more questions? Oh, by the way, you earned a token, man. Apparently, you can get a McLaren shirt. Is it a McLaren shirt? You can get a McLaren shirt. No more questions? Then. Well, and just enjoy. Thanks for being here, and enjoy the rest of the conference.